Hello friends, welcome to the channel Physics by IITians.
Hello friends, in this video we shall learn about a very important concept in basic semiconductor physics. So the topic we shall here discuss, that is mass action law. We shall find out what is it, and we shall also solve some questions after understanding what is mass action law. So let's start. What is mass action law? The law of mass action states that the product of number of electrons in the conduction band and the number of holes in the valence band is constant at a fixed temperature and is independent of amount of donor and acceptor impurity added. So at the thermal equilibrium, if you add some donor with the impurity of with the impurity amount, or if you add some acceptor with different impurity amount, but the mass action law states that the number of electrons in the conduction band and the number of holes in the valence band is constant. So in another words, if a pure semiconductor is doped with n-type impurities, the number of electrons in the conduction band increases above a level and the number of holes decreases below a level. Okay, so what kind of questions you may face in the examination? Let us discuss. Suppose a question is the pure silicon at 300 Kelvin has equal electron and hole concentration of 2 into 10 to the power 16 per meter cube. Now it is doped by indium to the extent 1 part in 10 to the power 7 silicon atom. Now if the density of silicon is 4 into 10 to the power 29 per meter cube, then the electron concentration in the doped silicon is 10 to the power 5 per meter cube, 10 to the power 7 per meter cube, 10 to the power 9 per meter cube, or 10 to the power 10 per meter cube. So what is here given? It is given that at temperature T equals to 300 Kelvin, there is pure silicon. So the concentration of hole and the concentration of electron will be same. That is given as 2 into 10 to the power 16 per meter cube. Now it is doped by the indium. So sum of the indium atoms will be doped to the silicon atom. What is that amount? That is 10 to the power 7, 1 part in that 10 to the power 7 silicon atom. So there are 10 to the power 7 silicon atoms. Suppose from the 10 to the power 7 silicon atoms, I take out one silicon atom, and in place of that silicon atom, I dope it by indium atom. Okay, so that is the meaning that it is doped by indium to the extent 1 part in 10 to the power 7 silicon atom. Now, the density of the silicon is 4 into 10 to the power 29 per meter cube. So, what will be the electron concentration in the doped silicon? So, this is indium, so there is some kind of impurity here. So, the question is, due to this impurity, what will be the change in the final electron concentration? Okay. So, first of all, this acceptor ion concentration, that is concentration of hole, is this is 4 into 10 to the power 9, 29 per meter cube divided by 10 to the power 7. So this is 4 into 10 to the power 22 per meter cube. Now the mass action law tells us N into P equals to Ni square, or you can write it as N into P equals to N prime into P prime. So N into P is the initial multiplication of this two concentration of electron and hole, and this is N prime into P prime is the concentration after adding some impurity to an intrinsic semiconductor. So here N prime, that is the electron concentration in the doped silicon, is N into P divided by P prime. So what is N and P? N and P is the pure silicon electron and hole concentration, that is 2 into 10 to the power 16 into 2 into 10 to the power 16 divided by this impure ion acceptor ion concentration, that is 4 into 10 to the power 22 per meter cube, that is 10 to the power 10 per meter cube. So here this is 10 m to the power minus 3, or this per meter cube. So the answer is 10 to the power 10 m to the power minus 3. So how do you understand that this is a question of mass action law? Here the if you are asked to find out the electron concentration or hole concentration, you should understand that what is given, if the concentration is given, then another concentration will be easily find out by from this mass action law. Next question, two pure specimen of a semiconductor material are taken. One is doped with 10 to the power 18 per centimeter cube number of donors and the other is doped with 10 to the power 16 per centimeter cube number of acceptors. The minority carrier density in the first specimen is 10 to the power 7 per centimeter cube. What is the minority carrier density in the other specimen? So there are two types of carrier. One is the majority carrier, which is mostly the giving contribution for the current, and there is another kind of charge carrier, that is minority carrier. So here it is asked that what is the minority carrier density in the other specimen. Now we have already discussed that the mass, according to this mass action law, N1 into P1 equals to N2 into P2. So N2 is N1 into P1 divided by P2. Now N1 is 10 to the power 18 into P1 is 10 to the power 7 divided by 10 to the power 16, that is the dopant. So it is, the answer is 10 to the power 9 per centimeter cube. So friends, this kind of questions you can easily find out and solve in the paper if you find it in the your entrance examination. So friends, our full length test series and subjective test series for NET examination has already started, and interview guidance package is already started, where we regularly discuss and guide the students how to prepare and how to answer the questions at the time of interview, and it will be helpful for concept clear and also for the qualification of examinations. So thank you for your cooperation. Friends, please don't forget to like and share this video and subscribe to the channel. Thank you.